Hello. Hello and welcome to this video. In this video, we will solve problem number 31 to 40. So grab pen and paper and try to solve problems yourself. When I'm stating the problem, pause the video, attempt the problem. If you cannot solve it, only then look at the answer. You should not spend more than 15 minutes on every problem. And if you can't solve it in 15 minutes, move on to next problem. The other thing would be that if you get stuck, take a break and come back and try to solve. It should work. Usually sleep works very well, you can't solve any problem. So one of the things which happens is you can go on solving problem. So a lot of problems are solved and then you start getting stuck. That usually happens because of two reasons. One is that the problem gets harder. Second is your mind gets tired. In that case, sleep and come back to the problems after you wake up. So the link to download the PDF would be given in the description. So without further ado, let's get started. Question 31 says that person has to send invitation to 6 friends. In how many ways can he send invitations to them if he has 3 servants? So clearly, each friend can receive invitation in 3 ways because there are 3 servants. So 6 friends can receive in 3 to the power 6 ways, 729. Question 32 says that in how many ways can 3 prizes can be given to 7 boys when each is eligible for any number of prizes? Now, each prize can be given in 7 ways. So 3 prizes can be given in 7 to the power 3 ways. Question 33 says that a telegraph has 5 arms and each arm is capable of 4 distinct positions, including the position of rest. What is the total number of signals that can be made? So each arm can occupy 4 positions. Thus 5 arms can occupy 4 to the power 5. That is 1024 positions or combinations or rather permutations are possible. But in one condition, all the arms will be at rest and no signal can be made. Therefore, total number of signals is 1024 minus 1, that is 1023. Question 34 says that a letter lock consists of 3 rings, each marked with 10 different letters. In how many ways is it possible to make an unsuccessful attempt to open the lock? So we will have a total of 10 to the power 3 combinations or other permutations because there are 10 letters and 3 rings. So 10 to the power 3 is 1000. However, one of the combinations will be successful. Therefore, total number of unsuccessful attempts that can be made is 1000 minus 1, that is 999. Question 35 says that how many numbers greater than 1000 but less than 4000 can be formed with the digits 0, 1, 2, 3, 4 with the repetitions allowed? So repetitions are allowed. That means 1000 place can be filled by 1, 2, 3. That is in 3 ways. Now hundreds, tens and units place can be filled in 5 ways from any of these 5 digits. So total number of numbers which can be formed is 3 into 10 to the power 5. This 3 comes from 1 to 3 and 5 to the power 3 comes from 5 into 5 for the 3 positions, 100 tens and units. So the total is 375. Question 36 says that in how many ways can 8 Indians, 4 Americans, and 4 Englishmen be seated in a row so that persons of same nationality sit together? So we can group them in 3 factorial ways. 3 groups can be grouped in 3 factorial ways. So when they are together, they form a group. So that is 3 groups. The total number of arranging groups is 3 factorial. 8 Indian can be arranged in 8 factorial, 4 Americans in 4 factorial, and 4 Englishmen in 4 factorial. Even within a group, they can be arranged in so many fashions. So the required answer is 3 factorial multiplied by 8 factorial multiplied by 4 factorial multiplied by 4 factorial. Question 37 says that there are 20 books of which 4 are single volume. and the other books of 8, 5, and 3 volumes. In how many ways can all these books are arranged on a shelf so that volumes of the same books are not separated? So we consider 3 groups of books which will be of same volume, that is 8, 5, and 3. So 8, 5, and 3, when you make, you have got 3 more volumes, okay? And 4 from the year. So 4 single volumes. So 4 plus 3 is 7. So we can arrange them in 7 factorial ways. But 8 volume book can be arranged in 8 factorial ways. 5 volume book can be arranged in 5 factorial ways, and 3 can be arranged in 3 factorial ways. So total number of arrangements is 7 factorial multiplied by 8 factorial multiplied by 5 factorial multiplied by 3 factorial. Question 38 says that the library has 2 books, each having 3 copies, and 3 other books each having 2 copies each. In how many ways can all these books be arranged in a shelf so that copies of the same books are not separated? So pretty much like 36 and 37. So we take all copies of the same book as one. So we have 5 books, which can be arranged in 5 factorial ways. Now copies are identical, so they can be arranged only in one way. Thus the required number of arrangements is 5 factorial, that is 120. Question 39 says that in how many ways 10 examination papers be arranged so that best and worst papers never come together? So first we check the number of permutations without restriction, that is 10 factorial. Now we combine both the papers and we assume we find that how many permutations are possible if both come together. So if you combine them, there'll be 9 papers and those can be arranged in 9 factorial ways. But the 2 papers among themselves can be arranged in 2 factorial ways. So number of permutations in which both are together is 9 factorial multiplied by 2 factorial. Therefore, number of permutations in which both are not together is 10 factorial minus 9 factorial multiplied by 2 factorial, which is equal to 8 multiplied by 9 factorial. Last question says that there are 5 boys and 3 girls. In how many ways can they be seated in a row so that not all girls sit together? So first we find the total number of permutations, that is 5 plus 3, 8 factorial. Now we take all the girls as one person, so we have 6 total persons. The number of ways these can be seated is 6 factorial, but 3 girls can be arranged in 3 factorial ways. The total number of ways where 3 girls sit together is 6 factorial multiplied by 3 factorial. Therefore, total number of ways in which girls are not together is 8 factorial minus 6 factorial multiplied by 3 factorial. That is 36,000 number of ways. So with this, we come to the end of video. If you have not understood any question, let me know and I'll further explain in the comments. Make use of comments in a generous way. Okay, whenever you have a doubt, ask me in the comments. I'll explain even more. Although these are very easy problems, new students might get stuck about how this is going to work, when to apply which formula and all. So I thank you for watching the video and download the PDF from the link in description. And make sure you periodically download. Actually, what you should do is you go to my website ashtabakar.org and look at the date of the book. This is 23rd April 2026. It was updated yesterday or day before yesterday. So if the date is later, then that means a new version has been uploaded. As soon as I find a typing mistake, I update the PDF. So download the PDF and study, do the hard work, and God will bless you. So once again, I thank you for watching the video. I will come again tomorrow with a new video from problem number 41 to 50. So till then, see you. Bye.